Hello everyone, and in this video we'll be discussing the concept of molar solubility, and we'll be talking about how to solve for the molar solubility of a compound using ice tables. We'll also talk a little bit about how to solve for certain questions after you've then solved for the molar solubility. So basically we will solve for the molar solubility of a compound, and we'll be able to solve for how much of that compound can be dissolved in a certain amount of water at standard conditions. So we'll tackle the first question first. So the first question asks us, what is the molar solubility of calcium fluoride, CF2? So the first step you want to do in doing this is to go ahead and set up your ice table. And before I set up the ice table, I'm going to go ahead and write out the dissolution of calcium fluoride here. So CaF2 is going to dissociate into Ca2 plus 2F minus. And that'll be your balanced equation. I'm just going to clean that up a little bit. Oops. So let me clean that up a little. There we go. So you can see our CaF2 became Ca2 plus 2F minus. So I will go ahead and write out our ice table. Like so. And if you need help understanding how to set up ice tables, there's a whole separate video on just ice that you can go watch. Okay? So now when we go into setting this up, remember that we don't include solids in equilibrium expressions. Solids are left out of the equilibrium process. So for that reason, we're going to cross out anything to do with the CaF2, because again, we don't want to include solids in our equilibrium expression. That's going to make things a lot easier to deal with. So now what we want to do is remember that since Ca2 plus and F minus are products, they start at 0, and they're going to increase in terms of x. Calcium is going to increase in terms of 1x. Fluoride is going to increase in terms of 2x. And the reason that it increases in terms of 2x is because its coefficient is a 2. So at equilibrium, calcium ions are going to be x, and fluoride ions are going to be 2 times x. So what we want to know is the molar solubility. And the molar solubility is going to be equal to x. So what we want to do is we want to solve for x. So what we will do is we will bring our KSP down here. So if in the question we're told that the KSP is 3.9 times 10 to the negative 11. And we're going to set that equal to the two products multiplied together. Because again, remember, we crossed out anything to do with the reactant. So we're just left with products. So we'll have x times 2x. And remember, we're going to square this 2x because of this 2 up here. So remember, when there's a 2 as your coefficient, you're going to square that expression in the equilibrium expression. So that 2x gets squared. Okay? So what you want to do first is respect the order of operations. You'll want to square this before you multiply the x. So what you want to do is 2x squared is 4x squared. So 4x squared times x is going to equal 4x cubed. So we squared the 2x and got 4x squared. Multiply the other x gives us 4x cubed. So what I'm going to do is rewrite that expression as 4x cubed, like so. Okay? So now what we want to do is divide this 4 out to both sides. Pretty simple. So when you divide the 4, what you'll end up with is nine point 75 times 10 to the negative 12 is equal to x cubed. Now this has become relatively simple to solve for x. And it's going to how you solve for x is going to depend on the calculator you have. So if you have a pretty decent graphing calculator, like a TI-80 series calculator, you'll be able to easily take the cube root of both sides. So take the cube root of x cubed, and then take the cube root of this 9.75 times 10 to the negative 12. If you don't have a graphing calculator or a calculator that can do cubed roots, you'll want to multiply this 9.75 times 10 to the negative 12. You'll want to not multiply, sorry, you'll want to put it to the 1/3 power. So if you don't have a calculator that can do cubed roots, you can also take this expression and put it to the 1/3 power. That's literally the same thing as doing the cubed root, except pretty much all calculators can do this second part here, and fewer calculators, although I suspect many of us have calculators, that can do a cubed root. So just in case you can't do a cubed root on your calculator, you can do it that way as well. And so when we take the cubed root of that 9.75 number, you'll end up with x equal to 2.14 times 10 to the negative 4. And so if you remember, our molar solubility is equal to X. So our molar solubility is equal to 2.14 times 10 to the negative 4 moles per liter. It's very important to include your units. So this would be your final answer. This is the molar solubility for calcium fluoride. So now that we've gotten this solved, we need to revisit the second part of the question. And the second part of the question is, how much calcium fluoride can be dissolved in 800 milliliters of water at standard conditions? So to do this, we'll need to do a little stoichiometry. So what we'll do is we'll start with the 800 milliliters. And we'll move into a conversion factor. So we want to move into liters. So you'll have to put that 1 liter is equal to 1,000 milliliters. And then once you do that, you'll do the whole, that's when you'll bring in this number. So you'll bring in this number in the second step of the stoichiometry. So we'll have 2.14 times 10 to the negative 4th moles over 1 liter. And then for the last part of the stoichiometry, you'll do the molar mass. Because I didn't put this in the question, I just realized, but we want to know how many grams can dissolve in 800 milliliters. So you'll want to convert this amount into grams. So the molar mass of calcium fluoride is 78.07 grams per mole. And so if you want to, you can pause the video to do this little stoichiometry here. And your final answer should be 0.015 grams of CaF3. So this is your final answer. So this is how many grams of calcium fluoride will dissolve in 800 milliliters of water at standard conditions. And there you go.